We get started. So welcome everybody to the Partners in Education Research seminar today with Josh Angrist from MIT. I just wanted to start by reminding people of just a few of the usual expectations, and that is that you ask clarifying questions throughout the presentation, but that you would hold like bigger picture questions till the end. If you're participating via Zoom, please use the hand raising function. And I promised Josh that I would be sort of monitoring the Zoom hand raising function just in case he misses that. You know,
do this. I might see you do this.
If you're watching via YouTube, and Josh, we have some people watching this on a YouTube stream, you should submit questions to PIER_fellowship@gse.harvard.edu, and Ashley will read them off to me. One final thing that is not a usual requirement, but which is something that Josh asked for, is please turn on your video cameras, just so I don't know, it'd be more interactive,
it's more like the real thing.
Yeah, right, exactly.
If you're in my econometrics class, you know, which we could say this is a version of, you have to have your video on to get attendance credit.
Yeah, that's right. So we're going to have at least those same standards here.
Awesome.
Right.
We're not actually going to grade the participants.
Well, you may not, but I will. Yeah. But I might. Yeah. All right. So in any case, I just wanted to extend a welcome to Josh Angrist, who's the Ford Professor of Economics at MIT and co-director of the School Effectiveness and Inequality Initiative at MIT, has been doing a lot of groundbreaking work using the school choice systems in a number of school districts around the country, but he's going to be talking about two of them, New York City and Denver, today. So without further ado, take it away, Josh.
Okay, thanks a lot, Tom. Let me just get the screen share going. And you guys see my slides?
Yes.
Awesome. Okay, so thanks very much for the invitation, Tom. It's a pleasure to present to the CPIER Partnering in Education Research seminar, and I'm looking forward to sharing the latest chapter in kind of an ongoing project, as Tom mentioned, at the School Effectiveness and Inequality Initiative at MIT. We've been engaged with kind of a hybrid research agenda that involves school matching and the measurement of school quality. And this chapter is joint work with my former students and longtime collaborator, Peter Hull and Chris Walters, and also with my MIT colleague, Parag Pathak. And there is some little irony in this talk for us, Tom, because you came to me, I guess it was 10 or 15 years ago, trying to get me interested in working on teacher value added. And you probably remember that. And I kind of poo-pooed it. I didn't think it was very well defined or likely to be meaningful. And I've since come to a very different view where I myself am measuring value added, though we focus on schools rather than teachers, but I think it's similar methodologically. So let's dive in. The background for this is everybody wants to know where the good schools are. Federal law says that states have to report on that. So this is a school report card. This is from the Bloomberg era in New York, so they present information like this somewhat differently these days. But essentially, similar types of content. There's also a burgeoning sector of independent information providers on schools. So if, for example, you're looking to live in a neighborhood or a town, a particular set of neighborhoods or towns, you might look at their school quality. How would you measure that? Well, if you look on Zillow, let's just say you're looking for a house in Berkeley, though I don't know why you'd want to live in Berkeley. It's very expensive, but one of our co-authors lives there. You would get this information on the Zillow website, which reports characteristics of schools, and it's grading the schools on a scale of 1 to 10. And so essentially the school quality is for sale across real estate markets in the United States. So we're very interested in knowing whether that's a reasonable measure of causal effects of school attendance. A lot of people think they know the answer to that, and they'll say, well, good schools enroll good students. And you see this playing out, this sort of view that the good schools are where the good students are. You see this playing out in the contemporary debate over exam schools, which I'm sure you're well aware of in Boston. So there's a lot of pressure to change the way exam schools are selective public schools. There's been a lot of pressure to change the way they admit their students. So this is Boston Latin School in Boston, along with a few others, and Stuyvesant and Brooklyn Tech in New York. So these are some older articles from 2018, but the discussion of exam schools has only intensified in the last 12 months or so. So we have something to say about that. We have a kind of a general lesson there. Some of you know this story, of course. News from Boston and also Chicago and New York. So let me give you a quick look at our take on, selective enrollment schools and the idea that schools can be judged by the quality of their students simply by comparing test scores. So here's a picture of Boston Latin schools admissions. Boston Latin, very highly rated, US News and World Report. Boston Latin is selective. It ranks applicants. Down here, there's an admission score. And what happens is if you clear the cutoff, so that's this line, you get to go, you're offered a seat at Boston Latin. It's a little more complicated than that. Boston Latin School is actually part of a 3-school deferred acceptance match. So I'm kind of abstracting away from the detail. But basically, because it's most people's first choice, you get offered a seat there if you clear the cutoff. So what is special about Boston Latin? Well, these are the average 6th grade math scores of your peers. And if you clear the BLS cutoff, you get to go to school with dramatically better peers. So the peers that you're seated with in either 7th or 9th grade, Boston Latin admits at both grades, are more than a full standard deviation higher achieving when they come in. So that's what parents see, and they find that very attractive. And of course, politicians react to that. Does that mean that Boston Latin School is the best school in the country or one of the best schools in the country? Well, of course, everybody may have their own standard there, but one of the ways that you could measure that is through achievement effects and examine whether kids actually learn more. So here's the same axis. That's the admission score. That's the cutoff. And these are the 10th grade English scores of applicants to Boston Latin. So you see the peers are far better. It's dramatic. But English scores actually fall at the cutoff. So there's a slight negative effect on achievement of being admitted to Boston Latin School. I'm not arguing that it's actually negative. It might be for some people, but it's certainly not this. So this is misleading. And of course, the problem that I'm highlighting, as many of you know, is the problem of selection bias. Selection bias bewitches us in all things education, I would say. People are tempted to make naive comparisons that don't adjust for pre-existing differences and draw potentially misleading conclusions. So we'd like to fix that problem. And we think we have a kind of a wrench, a tool that allows us to fix that problem, at least in a wide variety of K through 12 settings. And our tool to fix that problem is centralized assignment, as there is in Boston. So centralized matching allocates school seats in many large urban districts. The way that that works is applicants rank order schools according to their preferences. Schools may have priorities that they grant applicants. For example, if you have a sibling that's already in the school, you'll be higher priority. If you live nearby in some cities, you'll be higher priority. And then there's an algorithm that kind of brings those two sides together. The Gale-Shapley algorithm is our favorite, though there are others. It is Gale-Shapley that's the one that's most widely used in the United States. Now, why is that useful for us? Because applicants often share preferences and priorities. So centralized assignment algorithms use tie-breaking variables to distinguish between them. And the tie-breaking variable is often actually a random number. So it's a lottery number. That's what the public sometimes calls it. And basically, the upshot of this from the point of view of an analyst is that lottery tie-breaking turns decentralized assignment to schools turns centralized assignment to schools, I should say, into a stratified randomized trial. And we've shown how to exploit those trials in a series of academic papers, and we can post this handout later, and the handout has the links to the scholarly work. Besides the main paper I'm discussing. And we use those trials because there's an element of random assignment. We just have to figure out what we need to condition on. Then we can use those trials to learn about things like charter effects and school sector effects. And maybe we can even learn about individual schools. There are some complications here. So some districts use non-lottery tie breaking or a mix of, and some sectors, like the exam school sector is actually not breaking ties with a lottery number because those are selective schools. But turns out that that amounts to something like a regression discontinuity design, and we know how to exploit that as well. So we've solved that problem in another scholarly contribution that's linked in the handout. And so I'm just going to forge ahead and assume that you believe me when I say conditional random assignment of a C makes those attractive instruments for school enrollment. So let's go ahead and think about how to do that. Okay, so now I have an equation or two, not very complicated. Basically, the conventional value added story is you've got an outcome like achievement, but it could be high school graduation or whether you go to college. You've got some controls, and the controls, of course, are key. And then if there's J schools, you've got a dummy for each school. So you run that regression, and the coefficient on the school dummies is a measure of, at least as far as the dependent variable goes, it's a measure of school quality. And the hope there is that control for X is sufficient to eliminate omitted variables bias. So X is something like lag test scores, maybe it's got demographic characteristics, special education status, and that sort of stuff that's supposed to adjust for pre-existing differences between students. That's the conventional VAM approach. It may not be good enough, so that's where centralized assignment comes in. If XI is inadequate to eliminate OVB, omitted variables bias, we can use those randomly assigned offers from the centralized match, which are driven in part by lottery tie breaking. We can use those as a source of quasi-experimental variation that provides instrumental variables for DI. So the offers are ZIJ, which is a dummy for whether kid I was offered a seat at J. And the thing that we're instrumenting is DIJ, which is whether you actually go to J. They're not perfectly correlated because people don't necessarily go to the school where they're offered a seat. You can get in otherwise. There's often there's an ad hoc round. Sometimes it's called an aftermarket. You can decline your offers, but most offers are accepted. So that's a very powerful instrument. And in principle, it solves omitted variables bias problems for us very nicely. Now, there's a few technical issues that I would like to raise as I explain this to you. One is, the things that are not random, we call that type. So those are applicant preferences over schools and the priorities that schools grant to applicants. Those are not random. So for example, if you live near a school, maybe it's a high income neighborhood, so on average, you're higher achieving. I need to fix all that. People have different preferences over schools. That's typically correlated with their potential outcomes, correlated with their past achievement and potentially their future achievement. So that's a problem because this theta I, which we call type, is a very high dimensional thing. So in a match, for example, in Denver, where there's like 5,000 kids being randomized to sixth grade seats, there's almost as many types. There's 4,000 types out of the 5,000 kids. So I can't condition all that stuff away non-parametrically, but it turns out I don't have to. And the reason I don't have to is we can use the propensity score theorem and condition only on this very low dimensional function of type. the assignment propensity score. The assignment propensity score is the probability an applicant of a particular type with particular preferences, particular priorities, the probability that that applicant is offered a seat at school J. So there's one of these for each school. So there's a J on that and there's an I on that. And if I want to eliminate omitted variables bias from type, that is preferences and priorities, I don't have to condition on this high dimensional theta. I only have to condition on this low dimensional thing. And it turns out that there's a formula for that. And that becomes a very simple object. And so even though there might be 3,000 or 4,000 different types, typically the propensity score is shared by many applicants. So in a market like Denver's, the propensity score only takes on maybe 100 and some distinct values. So now I have a kind of a nicely designed stratified randomized trial where within strata defined by the propensity score, I have lots of treatment and control students and I can forge ahead and do my econometrics. Well, maybe, okay, so that's the first problem. And that's the problem that we solved in the earlier work. So we have two papers that derive the propensity score for general matching using deferred acceptance, which covers a wide class of matching algorithms. And we solved the problem of figuring out what the propensity score with lottery tie breaking and figuring out the propensity score with non-lottery tie breaking. So if we were to forge ahead with that, a simple way to control for the propensity score would be to use a risk-adjusted instrument. So this is something you could figure out with a few minutes of regression algebra. The way to eliminate bias from differences in propensity score, differences in assignment risk. Well, I could put a dummy in my regression for each value of the propensity score, but instead of doing that, I could just subtract the propensity score from the offer dummy. That turns out to be the same thing. So there's a bit of elementary regression algebra that show that. Let's say we want to do that, okay? So that kind of brings us up to the topic of the paper that I'm presenting this afternoon. Okay, I'd like to do this. I think I have instrumental variables. I've solved the problem that the thing I need to control for in the match that's not random is very high dimensional. I've boiled that down to propensity score. I have a very simple adjustment, which is to center the propensity score. Why can't I forge ahead and do VAM with that? Well, the problem is that I don't have enough instruments. So some schools are undersubscribed. And undersubscription happens for a variety of reasons. One big reason is not every school is in the match. Some schools don't participate in the match. Nobody applies to them. Maybe they don't have an entry grade that's relevant for that particular cohort, okay? And then there are people who are sure to be offered a seat at a particular school. And that has to do with the vagaries of deferred acceptance. So some schools are literally undersubscribed, which means that they have fewer applicants than they have capacity to seat, which means that anybody who wants to get a seat there can get a seat there, and that's good for them, but it's not very good for research. So when that happens, the propensity score is 1 for everybody, and you may have a mix of different types such that the propensity score is either 0 or 1. Okay, so if the propensity score is 0 or 1, you can think about a clinical trial. It's not a very good clinical trial if everybody gets the treatment or nobody gets the treatment. That's a poorly designed clinical trial. So that happens at some schools in centralized matching. And that's the problem that this paper comes to solve, the undersubscription problem, okay? Degenerate risk is no fun. It might be good for families, but it's no fun for research because my centered instrument is 0 for everybody. The actual offer dummy equals the propensity score when everybody's propensity score is all 0 or all 1. Okay, so the only schools that we have valid instruments for are oversubscribed. That's where the propensity score is strictly between 0 and 1. And then we can use it as a source of quasi-experimental variation. In practice, there's of course a lot of borderline cases where schools are not heavily oversubscribed. So the instrumental variables estimates are going to be noisy because most people get seated there who want to go there, or few people get seated there who want to go there. So, there's sort of a spectrum of the degree to which the instrumental variable strategy is going to work. So that's the problem we come today to solve. And the details behind that I'll leave for you to take a look at if you're interested in. I want to skip now to our solution. So we have two solutions. The first one is me and my RC. Okay, so my RC is RC VAM. Here it says on the can. Okay, RC VAM is what we call risk-controlled VAM. So it's essentially a step back from instrumental variables, but it is grounded in some understanding of the process that generates a school assignment in centralizing districts. Okay, why are cross-school comparisons misleading? Well, one thing, of course, is that students choose schools. So families rank schools in a manner that's correlated with their demographic characteristics and their past achievement. Schools pick students to some extent in centralizing districts. Seats go to eligible applicants, prioritizing, for example, kids who live nearby. Now, conventional VAM mitigates the first source of selection bias by conditioning on demographic variables and things like free lunch and SPED status, and then of course lagged achievement, which is very valuable. The RC-VAM strategy says, rather than this kind of proxy control, we're going to condition on everything we know about preferences and priorities. In other words, we're going to condition on the propensity score itself, but we're not going to do IV, we're going to do OLS. So the RC-VAM estimator is OLS, in other words, a regression on school enrollment dummies, but it adds the propensity score controls as if we were doing instrumental variables, okay? Now, what assumptions make that plausible? So this idea actually has a very respectable pedigree. We came to this by thinking about a paper I love that I teach and that features in my book for undergrad metrics. And it's a great illustration of the power of regression to turn night into day. And that's the Dale and Kruger study of college selectivity and whether it matters if you go to a more selective college for your future earnings. And the Dale and Kruger idea is basically to condition on, and they have some unusual data that allow them to do this, to condition on the schools that I apply to and the schools that I got into, and then to treat whether I actually go to a particular school as if it's randomly assigned. In other words, independent of potential outcomes, okay? So that turns out to be the basic idea behind the RC-VAM estimator. So let me build up to that very quickly. We have, this is the random part of potential outcomes. So Y0 is my potential achievement in some reference school that's going to provide the point of comparison for VAM. So we do have, as a matter of institutional fact, that offers, so that's the vector of offers generated by the match, are independent of Y0 given the propensity score. So that's a point of comparison for identification assumptions. Conventional VAM says potential outcomes are independent of where I actually go given X's. RC-VAM says potential outcomes are independent of where I actually go given X's and risk. What does that have to do with Dale and Kruger? Well, there's a lemma in our paper that the Dale and Kruger assumption, which is that potential outcomes are independent of where I go to college, conditional on whether I apply, so that's like in my propensity score, and whether I was admitted, that's as good as randomly assigned or ignorable in Rubin's jargon, okay? It turns out that that Dale and Kruger assumption implies our RC-VAM assumption, okay? So the idea is now that you have made your choices and you've been given your opportunities, the situation, the circumstances that lead you to pick school A or school B, that could be treated as idiosyncratic. Now, I can't actually say that that's literally as good as a randomized trial, but it does solve the undersubscription problem. And then it also, it is testable, okay? So I'll come back to that shortly. We do have a kind of a plan B, which is, yeah, sorry,
Josh,
question?
One quick thing on this, just sort of an observation is that basically my risk is being driven just by my choices and
also by your priorities, Tom.
Right, yeah.
Yeah.
But what's remarkable about that is, like, so say if two people have listed the same choices, but one has like bypassed a lot of lower scoring schools in order to pick those options. And so like they've signaled that they're willing to pay a huge price in terms of being able to travel across the city. And somebody else who just for whom those schools just happen to be nearest to their home. So they're not expressing like, you're not learning much about like how much they're valuing the achievement of the school. So
They might be different.
yeah, you might expect that sort of their outcomes late, like the person who's willing to travel a long distance is saying, look, I really
But so RCVM is not a slam dunk. It's not as good as having the random assignment of the instrumental variables strategy, but it does overcome the under-identification. The other thing is, Tom, in your scenario, if there's a neighborhood priority, I would know that the kid is closer. So I might be able to control for that.
Yeah.
We do have sort of two other things that we can do about that. One is we can still use the randomized offers to test the RCVM assumption. And we also have an IVVM strategy that I probably won't have time to describe in great detail, but I'll sketch it for you, where we can kind of resurrect the instrumental variables approach. So let me tell you briefly about the testing, okay? So suppose that alpha J is some VAM estimator, and this is really builds on something that was in an earlier paper that Parag and Chris Walters and co-authors and I published a few years ago. So here's the relationship between causal VAM and that VAM that may or may not be a good measure. And there's a residual in that equation. We call that a forecasting equation. Substitute that into a causal model for achievement, okay? So this is the VAM of the school that I go to. Okay, the VAM validity hypothesis is that this thing is equal to causal VAM. So if that alpha J is really a good measure of VAM, then if I randomize this should be equal to 1. In other words, it should predict my achievement perfectly. And so there's a test statistic in that. And we have some development of that idea in the paper. Does RCVAM actually predict achievement when the RCVAM or any other VAM, we can do this for any VAM, is assigned randomly by instruments? So that's a question we can ask even in an under-identified model. And we have a variety of things to look at there. One is whether that forecast coefficient is that 1. And another is this literally a perfect predictor? So maybe that residual is 0. It turns out that there's a kind of a link with classical over-identification testing that allows us to examine those things. If we actually had enough instruments, this would be a Hausman test where we're comparing the just identified IV estimates with the low OLS estimates. So that's something I'm going to want to show you. The other thing that we do, and this builds on some work by Michal Kolasar and co-authors using a kind of an argument around many invalid instruments, is if we can't fix, if we're not happy with the RCVAM thing, maybe for the reasons Tom was suggesting, we can come up with an IV strategy that works. And the IV strategy that works is a dimension reducing idea also, sort of like the propensity score, though the mechanics here are different. We say, well, there's a set of mediators, and the mediators are what drive school quality. And ordinarily you might say, well, why should there only be a few mediators of school quality? And that would be a fair point. But we do have some good candidate mediators. So even if naive VAM or RCVAM is not perfect, it should capture a lot of the variation in school quality. And it might be that once I know that, most of what's left over kind of averages out after averaging over different schools. So that's our IV VAM idea. And basically what it amounts to is instrumenting this vector of mediators and again, testing. So we have a test, we have a specification test for the validity of the mediators. Does that vector of mediators satisfy an exclusion restriction which justifies this approach? Okay, so let me now move on to the empirical work, and you'll see these ideas, deployed in pursuit of actual causal effects. And then I'm happy to have more questions about what these findings may mean and how they should be used. So Tom mentioned we do in the paper, we study both Denver and New York, but in the talk I cover only New York because I don't have time really to go through the Denver application as well. So New York City is a wonderful setting to study value added. Of course, it's a very large district and it has many schools, and it has a centralized match. It's interesting from the point of view of school assignment because it has both lottery tie-breaking and non-lottery tie-breaking. So it allows us to test out our ideas in that domain. How does the actual match work? So the entry grades are middle school, 6th grade, and high school, 9th grade. Students in New York apply to programs rather than schools. So a school may host multiple programs. And then priorities are granted based on neighborhood and sibling status and a few other characteristics. Some schools in New York are lottery schools, so the tiebreaker there is a random number. And then, and recently you may have read about this because this is part of the debate over exam schools. New York has a very large sector, what's known as a screen school sector, where these are schools that rank applicants by something that's not their preferences and it's not their priority, but it's not a lottery number. It's something like a test score. So there are elite schools within that system, like Townsend Harris. There are schools that rank people by auditions and that sort of thing. Anyway, we have to figure out how to deal with all that. So that's kind of behind the scenes. And we have a whole paper on that problem, and we think we have an elegant solution. What I'm going to show you today are just a handful of results. We have results for the effects of going to a particular middle school on 6th grade achievement, and we have results for the effects of going to a particular high school on SAT scores. Okay, so here are some descriptive statistics from New York City. These are for kids in the match. Actually, we have all three settings here. So let me focus on New York Middle and New York High School, and I'll skip over Denver. So kids in the match in New York, 186,000 applying to middle school, 122,000 applying to high school. Not everybody has risk. So some people are sure to be seated in the set. Now, when I say sure to be seated, I don't mean where they go, but I mean where they're going to be offered a seat. So many people are sure to be offered a seat at a particular school, meaning their propensity score is 0 or 1, and that's the problem we want to solve. So kids that have risk are a subset of the full sample. We should worry a little bit about how special they are. We see that actually they look reasonably similar. So if you compare, for example, here's the race breakdown, New York City middle schools, looks reasonably similar whether or not I have risk. New York, like many large urban districts, is mostly non-white. So 40% of New York kids in the middle school match are Hispanic, 23% are Black, only 15% are white. Most qualify for free lunch. Many, over 20% in middle school, qualify for special education services. Many are English language learners. Here's baseline scores from before the match. That's a 0 by construction. Okay, so that's my data. And the first thing I want to show you is, it's a lot of information. It's got the VAM thing, so we need to boil it down. There's, 674 schools, so we don't want to look at VAM for every single one of those schools, as interesting as that may be if you're looking for a house or an apartment in New York City. Okay, but from our point of view, it would be overkill. So here is a version of some of the facts about that. This is a kind of what we call this a visual instrumental variables plot for New York City middle schools. So this is the effect on this axis. Each one of these points, the two coordinates, the one on the x-axis is the effect of being offered a seat at a particular school on VAM, okay, as measured in different ways. So here is the first stage effect on OLS VAM measured naively with very few controls. We call that uncontrolled. And then here's VAM measured with conventional controls. Those are things like FRPL, SPED, and lag test scores. These are controls for propensity score only. These are the RC-VAM controls, which control for both propensity score and lagged achievement, and the conventional VAM control. So the question that this figure asks and answers is the first stage effect on OLS VAM predictive of what actually happens to my later achievement? And you can see that when OLS VAM is measured poorly, this is very far from the 45-degree line. So this is our test statistic. So this is a consequence of bad VAM. When you have a naive VAM estimator, you increase that. It doesn't actually produce additional learning for those students. So the fitted value of the plot of the reduced form offer effect against the first stage effect on OLS VAM is well off the 45-degree line. Now, it turns out that in New York City middle schools, conventional VAM is very good. The predictions generated by conventional VAM estimates, at least for our achievement measure here, okay, very much align with the conventional VAM estimates. So this line now, when I use conventional VAM and I ask, what's the effect of being randomized to a higher VAM school? That falls pretty close to the 45-degree line. If I just use risk controls, I don't do as well actually as conventional VAM, but if I do RC VAM, the forecast coefficient here is almost 1. So RC VAM almost perfectly reproduces the consequences of being randomized to a particular school offer. So that's impressive. And it's even more impressive for high school. Erase all that. Because the lag score results for high school are not the same as the outcomes. So one thing that's going on in middle school, we have the luxury of using standardized tests. We have the luxury of using standardized tests, and the standardized tests that we're using as lag score controls are similar to the standardized tests that we're using as outcomes in the middle school setting. But in the high school setting, the standardized tests that we're using as lag score controls are not the same as the outcome. The outcome in the high school setting is an SAT score. So this is the reduced form effect on SAT scores. And again, you can see an uncontrolled VAM, so kind of what you might see on Zillow or a school report card, is misleading from the point of view of what actually happens to people who are randomized an offer at a particular school. Conventional VAM is better. Risk only is about as good as conventional, not quite, but RC VAM does very well. And so we think that's a nice validation or vindication of RC VAM. Peter, did you have a question? Do you want to go ahead and shout it out?
Yeah, so I say the p-values are changing as we go across these different first stage estimates. I mean, how much should we be thinking about just the fit on the 45-degree line versus what's the trade-off?
That's the p-value. Sorry, go ahead, Peter.
Oh, no, that's it, John. That's it.
Yeah, so that's the p-value for our specification test for the goodness of fit of the line. And in fact, you know, consistent with the visual, it blows out of the water, right? It definitely doesn't fit. So that's our test statistic. Definitely doesn't fit. Marginal rejection here. Conventional VAM is pretty good. Conventional VAM is surprisingly good. So if you just kind of get controls for lag score, you do pretty well. But then, you know, RC VAM is awesome. Works very well. So the combination, okay, so that's what the test statistic is telling us. So even if you don't like the p-values as kind of a literal probabilistic statement, it is in a sense kind of an R-squared for how close you are to a coefficient of 1, how close the point. So the null hypothesis is that this is a perfect line, and actually you can't reject that. So that's kind of impressive. And you can use it also to rank the VAMs. Even if you don't want, and I would hesitate to take an overly literal view of the distribution of that test statistic, but I like to use it to compare.
Josh, in the, how much of the divergence for the New York City high schools is the fact that the test being used is not the SAT versus the 2-year lag? Like, is it So like you could mimic this with the middle schools by saying, okay, suppose I use like third,
Older,
either a later outcome or an even earlier lagged score, like a 2-year lagged score. Do you know?
that's a great point, Tom. So that's part of it, but I think the bulk of it is the fact that the control is different. So the control is not as perfectly aligned with the outcome. You're right that there's a question of how long ago the lag is. And actually, I'll comment further on that shortly, because that's relevant in the COVID scenario in 2020, where, districts skipped their spring tests, and many probably will skip again this spring, which means, that has many consequences, of course, and it's far reaching. But from the point of view of our agenda, it means that lag score controls for VAM are degraded somewhat by having older tests only. So I'll come back to that, and I want to discuss that. Before I do, so anyway, the point of this figure, and I think we were kind of surprised that this works as well as it does. It also works well in Denver. We looked at Boston. It seems to work well there. So there's sort of two messages here. One, so this is a complete recanting of my position from 15 years ago, Tom. Conventional VAM is quite good, which is good news because not every district, at least where we've seen it. So conventional VAM is quite good, and then RC VAM is even better. Now you can only do the RC thing when you have centralized assignment, but many districts do. Here is a mean squared error comparison of IV VAM and conventional VAM. So IV VAM is that mediation idea where you say, I'm going to assume that the things that drive school quality are proxied by my best OLS VAM estimate. So maybe that's RC, or maybe it's just conventional VAM. And then there's a few other things that I'm going to add to that, like whether it's a screen school or whether it's a charter school and stuff like that. So let's start with this one. So this is root mean squared error in around the truth, computed by a combination of an analytic formula and simulation. As you can see, OLS, uncontrolled OLS has huge mean squared error. The red part is variance, the blue is biased. Uncontrolled OLS is badly biased. Using IV and that low dimensional model of mediation kills a lot of the bias at the cost of raising the variance somewhat. So if you, for whatever reason, you were constrained to use uncontrolled OLS, you could fix it by doing IV VAM with a low dimensional model of mediators. Conventional VAM is even better. IV VAM doesn't actually improve on that. It reduces bias. Maybe you care about bias more than variance, but it raises variance. So the net mean squared error is a little higher. RC VAM does very well. No IV needed. All IV does there is increase variance. So you really wouldn't want to go for it in that case. You would settle for IV, for OLS RC VAM, and you'd be happy. Now here is something we were just discussing. If you were constrained to use older lagged score controls, that would degrade the mean squared error of your VAM estimate. So, though it's not dramatic, this is conventional VAM with somewhat older lag score controls. So that makes mean squared error higher, but it's not a disaster. So let me conclude now with a few thoughts on the VAMdemic, okay, and what this means for what's been going on with testing programs. And here I take a little risk. This is less of a scientific discussion, but somewhat more impressionistic. As I said a moment ago, the pandemic has disrupted spring testing programs. It's not a VAM reliability disaster. So some people have sort of seized the opportunity, I think largely groups that are hostile to the VAM enterprise from the get-go have said, well, now we didn't test, we should just scrap the whole thing. So actually our earlier paper addresses this point by showing that, if you have 4 or 5 years of data and you drop a year, that's not a disaster for VAM. That doesn't hurt VAM terribly in terms of reliability And I mean predictive reliability in the sense of those VIV figures. So the absence of 2020 data does not justify kicking accountability efforts to the curb. It would be a shame. We're coming into the spring testing season. It would be a shame to lose yet another year. In Massachusetts, at least, with most kids back in the classroom shortly, if not yet. A trade-off here, I think, is primarily one of instruction time. So, you might be very reluctant to give over instruction time to a testing effort. On the other hand, the testing effort is essential to diagnostics. You'd like to know, where kids are failing, which groups are struggling, which schools need help, and so on and so forth. So I would come down in favor of doing the test, even at the cost of the classroom time that it takes. Back to the more technical concerns, the most reliable VAMs, and this is true whether we do the RC thing or not, the most reliable VAMs control for lagged achievement. In fact, and I don't show this in the talk, but we have some estimates in the earlier paper, just doing a gain or a progress measure goes a long way to providing a reliable VAM. But the best control strategy is a strategy that uses, as we were discussing before, Tom, relatively recent achievement. And as you go back, we have 5th grade lag scores for the 6th grade, okay? So the primary cost of skipping a year is having to reach back further for those lag controls. And of course, also some of the kids are going to drop out of the sample because they won't have been in your system. So the enterprise, the VAM enterprise is compromised by that. Finally, my last point, and then I'm happy to discuss and take further questions. RC-VAM without lags, risk only, and conventional VAM with stale lags, meaning older lags, are both notably improved by IV-VAM. So if you have the quasi-random assignment and you don't have the lag score, we're offering an action item there, something you can do to improve the quality of your VAM estimates. Okay, so that's it. Healthy VAM in 2021.
So thanks, Josh. For people who have questions, I'll be, please raise your hand, and then we'll go through them in order of hands raised.
Don't be shy, guys. If it was my econometrics class, I would be cold calling, of course.
So Josh, why don't I get started? Am I right in thinking, so basically what you're doing here is you're saying, all right, people are revealing things related to their future achievement when they're describing their school choices.
Totally.
Beyond just their baseline achievement and demographics.
Right.
Am I right in thinking, though, that that same idea could be applied, even though you're using this to estimate school value added, you could use school choices as use your propensity scores in a teacher level value added calculation, because there'll be variance within school, people are going to the same school, but won't there be variation in the choices that they've made?
Well, the match only assigns me to schools. Right?
Yeah. I know, but say now that I've got that information, I could still do now I include that propensity in a teacher value added model. Even though the match didn't assign me there.
That's an interesting thought. I mean, I've thought a lot over the years, and this shows how far I've moved from my dismissive view of, a decade and a half ago. Is it possible to distinguish school quality from teacher quality? Is a school not just the sum of its teachers? And it may be, but I'm not sure that this method does that.
No, but all I'm saying is, you're saying here are some additional regressors when you're trying to estimate school value added,
Right.
which is just these propensities. And what I'm saying is, well, couldn't you just, there'll be variation in those propensities within a same classroom. Couldn't you just add those?
True. Because people were more and less likely to be assigned to that school.
Yeah,
Yeah, but if you thought, so it depends what you think the source of bias is in teacher VAM. You know, I think the usual story about teacher VAM would be that kids are being assigned, you know, systematically within a school. So there's a teacher that's known to do well, maybe with lower achieving kids from the point of view of what they have when they come in. There's another teacher that's unhappy to have a lot of special education. Now, actually, if it's that, I could condition on that.
yeah.
So, and if all the principal sees is what I see, I can condition on that. So if the principal or whoever does that assignment has the same information that I have, I can condition on it. But then you have to think about, well, what's the source of variation there? It's a little harder to think about, but it would be interesting to do. I mean, it would extend, for example, to class size as well. So if it's going to work for teachers, it probably works for
Yeah,
class.
right. Yeah, yeah. Like, so
So
it's
again,
just
I
like,
would have to raise the question of how could I estimate both of those? Well, I could use regression to do it.
right. But what you're saying is there's more in these systems that use these centralized choice plans. There's information that's related to students' subsequent
Potential.
performance in these
Totally.
propensity scores that we could be using for all sorts of other, you know, things, even
That's right.
beyond just schools.
I would love to try it. We don't have the validation, so we don't have random assignment to classrooms at any level, except occasionally exotically in something like Tennessee Star. Not to my knowledge more recently.
Well, there's the MET study, but
You have random assignment to classrooms there?
yeah, in the second year, yeah.
So that would work as a test bed. That would be great to try.
Eric.
Yeah, hi, Josh. Thanks. And my question sort of builds on what Tom was saying. In fact, maybe what he says helps me sort of articulate my question better. So if I'm understanding correctly, RCVAM uses the information on preferences that is gathered as a result of the choice system, but it's sort of incidental in that way. You're using the actual assignments to validate the RCVAM or to think about the RCVAM. So this may be more in the realm of sort of speculation, but imagine that we could gather information from parents about their preferences over teachers within the school, even if we didn't use it to actually assign students, or we had some information from the principals, school principals, about how they thought about sort of something similar, like how they thought about that.
Well, that would be the best. So the best scenario would be algorithmic assignment within schools.
Right.
Which,
does the algorithm need to actually be carried out, or if like we solicited that data from principals about like
how they do it?
Yeah.
You might imagine there's sort of a Maimonides rule type scenario where, but it's complicated because it's matching. Years ago, Kevin Lang and I wrote a paper about Medco. And, Medco kids, this was about the effects of having Medco kids in your class. It's not the effect on the Medco kids, but the Medco kids are kind of a treatment for the kids in Brookline, which is the district we study. And we uncovered a kind of an algorithm for how many Medco kids you got in a classroom. And that's the best scenario for research. It may or may not be the best scenario for social policy, but we certainly potentially learn a lot from that. It could be that there are rules about teacher assignment that have that flavor. I remember once, when we published that paper on exam schools, the Elite Illusion paper, quite a while ago now, the Boston Globe did a story on it. And I was tasked with speaking with the principals of the 3 Boston exam schools in advance of the story. So that was a very challenging moment because the results there show that the exam school effect is illusory. It's all selection bias. And at least as far as the things we were measuring, it doesn't matter whether you go to an exam school. And one of the exam school principals commented to me that the only teacher she gets to pick is her Latin teacher, and that the rest of it is done through a variety of seniority provisions in the union collective bargaining agreement. So that's a potentially, there's just a thought there that if you could get a hold of that and dig into those provisions, this has definitely got graduate student thesis written all over it. You could figure out, some sort of identification out of that.
Yeah. Yeah, and the other key advantage here is you're taking this high dimensional thing, which is in this case school preferences, and turning it into the propensity score. So like one example is in my sense is that in high school, like once you know the set of courses that a student is planning to take, like there's only so many combinations of teachers that are possible, right? For kids who have stated like, I'm going to take Spanish 3 and, calculus A, B, or whatever. So, but that's very high dimensional because just like schools, there's sort of a very large number of choices. Anyway.
Well, yeah, that's an interesting idea, Eric. I would love, so you need data on kids' schedules. I guess exposed what they took. Yeah. Peter, did you want to make a comment?
Yeah, my comment is trying to think a little bit more about the variation. So since you're comparing folks who have the same preference set but who make different choices, do you have any evidence as to whether or not they're trading off test score value added against some other kind of value add? Maybe that helps us to understand why they're making the choices. I know the purpose of the paper isn't to like dig into where the variation is coming from, but it's just to kind of exploit the variation for identification. But
what we need to think about, so it's
thinking about like Bo Jackson's like work where he conceptualizes schools as these multi-product firms. Like, are they trading off like test score value add against, say, for example, like crime value add or something else like that?
Crime value added, it's a little harder to think of that as I guess you could say there's within school crime, but alternative outcomes are certainly of interest here. And there's a kind of a spectrum from things that are not so far removed from test scores, like high school graduation and then NSC, college. Our work tends to find, meaning the papers that my co-authors and I have written, we often find very similar results across those domains. We don't find that the test score results are hugely misleading. Like we have another paper on New York where we look specifically at whether a school in the Bloomberg lexicon was graded grade A, a good school. And we estimate effects on graduation and college. And, we find very modest grade A effects on those things as well as on achievement, so that the grade A measure is mostly picking up selection bias. There's a whole range of SEL, as it's called, of course, and this is in Jackson's work, outcomes that are, now more distant from that, things like behavior and engagement with criminal justice. And that's something we're interested in exploring, but we don't have any results on that. I would love to do VAM, with centralized assignment for that stuff.
Yeah, if I can follow up just briefly, do you find that the conventional VAM and your RC VAM produce very similar estimates, although they're using very different variation? In some sense, like what this is suggesting to me is that, well, maybe it isn't that the RC VAM is picking up like particular idiosyncratic trade-offs that's happening for the folks who have the same preference set, but are choosing different options. And so then maybe that opens up a different question, which is to say, are students making mistakes, right? And are there some equity considerations for this? If you were to break this analysis based on, let's say, socioeconomic status or race or something else like that. And again, I recognize that this is like out of the scope of the work, but
that's a good question, but it's a little bit of a different project. So my colleagues, Pathak and Walters, have written about, what parents are pursuing, what they perceive parents to be pursuing. The parents do seem motivated more by peer achievement than than by causal value added. And that is a problem for advocates of school choice, that, parents, it's a hard thing. I would say that it's the same thing in healthcare. It's very hard to figure out whether it's a bad or good hospital because you're not equipped to adjust for the type of patients that they serve. And we see the evidence of that in schools. The consequences of that are far reaching, because if parents only chase peer achievement, we're all sort of chasing homes in Lexington and Newton, and that drives up prices in those districts. And it may not be justified by school quality. So, my answer to that is I would like to encourage school districts and anybody else who cares to publicize less biased measures of school quality that purge the obvious sources of selection bias. It's a very, we had our school summit in February. Tom was there, gave a talk. It's very hard to convince people that this is something, even educated people like my colleagues. If you ask when we hire a new faculty member, we'll have a discussion, when we have lunch together. Back in the old days, we used to have lunch together. And they'll say, where are the schools good? And people will say, oh, Newton. And all I know about Newton schools is that, Andre Schleifer and Duran Asimoglu live there. I don't really have any good evidence on school quality in Newton. So, but if I make that point, it doesn't cause anybody to want to buy me lunch.
Actually, Josh, one of the downsides to this is not just that we're not providing, people are chasing inaccurate measures of school quality. One of the downsides is the implications are really different depending on your own socioeconomic status. So like if I'm like, so if families are looking for schools where they're not in the dramatic minority in the school, if I'm looking for a school where maybe there's some integration, but where I'm not like 5% of the, the population, I might perceive like a trade-off between racial matching and school quality when my measure of school quality is just peer, like the PIER's baseline achievement. But if I'm, and so that creates a different trade-off for white families than for African-American families. But if I'm using school value added, there's a much less of a trade-off, there. So the effects of housing choice. Yeah.
So Parag and Chris's paper is a little bit discouraging. On the other hand, so they have this study of what parents value. And actually, Jesse Rothstein years ago, his job market paper was on the same basic idea. But if you look at Boston, Boston has a very successful charter sector. And we know from work that we've done together, Tom and I and others, that Boston charters boost measurable things very sharply. And that's convincing from lotteries. Parents do seem to demand those schools. So there's some evidence that produces demand. At the same time, what's harder to explain is the demand for exam schools. That's the more discouraging, the huge fight about exam schools. I think that's the wrong discussion. First of all, most people don't go to those schools. It's just a handful of schools. So if your goal is to help low-income families or minority families in urban districts, that's kind of a sideshow. But then, it doesn't actually seem to matter very much who goes to those schools. So why are we fighting about it? Let's look at other things. Somebody wrote an op-ed a few days ago, actually, on this. I think it was in the Globe,
Hmm.
essentially making this point and going back to our paper to make this point. Yeah. So, but it's very hard to convince people. And again, I think about my friends and colleagues. It's very, my friends in Chicago want their kids to go to Peyton and Northside, and my friends in New York City want their kids to go to Stuyvesant, and here in Boston, and for many white families, that's the only public school they'll consider when it comes to high school. And that seems like a shame. So we try to put out a more nuanced story, but we can put it out. We can't make you read it or believe it.
Other questions? Folks have? In any case, Josh.
Is that Tom? And I think Mary has a question in the chat.
Oh,
Yeah, I was just about to chime in. In the chat, Mary has a question.
oh, okay. Sorry. Which Mary? Mary Lasky?
Mary Grass O'Neill.
Mary.
Mary, you can read your question. So, our paper on exam schools did receive a lot of publicity, and people go back to it. And there is, for example, this article this week. So it's not that it's ignored, but it's counterintuitive. People tend to say, well, I believe what I see.
Well, Josh, I think your explanation for what the principal said, though, might help people understand, help people believe
why my story has some merit.
Yeah, if you could say, but wait a minute, like if the staffing decisions are based purely on seniority, and school principals can make very few staffing decisions, that's a different, then it's like, oh, now I get it. Right. Now I understand why it may not matter as much.
That's right. And I think, for people who care to think about it, that's helpful. But, I have many colleagues who, I'm talking about my colleagues here who are thoughtful people who, for one reason or another, they're sure that this is not the right answer. Sometimes they tell a story. Here's the article. It's by Tom Keene from a few days ago. So Tom Keene is very much drawing on the elite illusion narrative in this Globe magazine piece from a few days ago. So it's definitely not ignored, but it's a hard sell.
I think you have to start writing op-eds, Josh.
I thought about it. Yeah.
Actually,
when other people write about my work.
So it's ironic, but that Tom, actually the way you pronounce that last name is Kane. That's in Ireland. That's Kane. But
It was a very compelling article.
Yeah.
Thank you.
I love it.
The Sunday Globe magazine, big piece, very powerful.
Yeah, so I was very happy to see it, but I don't know if there'll be that many families that are convinced. The Globe, to their credit, they ran that point of view, but almost every day they have something arguing about exam school admissions. And it's fine. I'm not against increasing minority representation in exam schools. That might be a fine thing to do, but it's unlikely to have any human capital consequences for minority students or anybody else. So it's in some ways it's a glittering distraction. Who gets to go to the Boston Latin School?
So to help make the case, my question was about the first within your metrics, right? The sort of rank correlation or the rank disagreement, if you were to rank it based on conventional VAM versus RC VAM, just to give a sense of the magnitude of the disagreement. And then, of course, to contrast and maybe get to Mary's point a little bit, right? What's the correlation between that and dumber measures like percent proficient to really hammer home the point, I think would be useful.
Yeah, so that's a good point, Andrew. So you might think actually the ranks are highly correlated. We have some other work showing that we'll have another paper sort of on that theme. This is primarily a methodological paper, as I'm sure you guys can see. We have some other work sort of on the consequences of bad VAM. So one of the consequences of bad VAM is it's highly correlated with race. So the schools that look good are the schools that have more white students. So people chase those schools and they chase those neighborhoods. But that's kind of a separate agenda. We want to point that out. What is bad VAM correlated with, and what is good VAM? Of course, it couldn't be a theorem on that. So it's specific to the cities that we're studying. But in the large urban districts that we're studying, causal VAM is mostly unrelated to race.
Okay, so I just wanted to thank Josh for joining us today for this fascinating seminar. And I just wanted to invite people to come back on April 27th. When we'll have Jens Ludwig joining us here for the seminar. Meanwhile, there are a handful of students, Josh, I think we warned you about this, like a brief post-seminar discussion.
Okay, so I should stay on Zoom.
Yes.
Correct.
No.
You